Good day, class. My name is Adrian James, electrical instructor. We will be examining this topic, transformer. We want to consider what is a transformer, types of transformer, uses of transformer, and maintenance of transformer. Let's start the definition. What is a transformer? A transformer is an electrostatic device which change voltage value without change in frequency. It changes the voltage values without change in the frequency. So, because of that, we have types of transformer. Basically, when we are talking about types of transformer, we have two major types of transformer. We have what we call voltage transformer and current transformer. So these are the types of transformer. But the voltage transformer is divided into two. We have step up and step down transformer. We have the step up transformer and the step down transformer. Most of the time, when we are talking about transformer, most of the time we revert to voltage transformer because of its usage. When we are talking about voltage transformer, be it step up or step down, has major application in time of transmission and distribution. And when we are talking sometimes about step down that have to do with electronics loads, we also talk about what? Step down transformer. So voltage transformer is divided into two, be it step up or step down. So I'll just give us how can we identify them. Either for step up, step down, these are what we are to examine. We have the primary windings and the secondary windings, sometimes called coil. By the time when the primary windings or sometimes turns is higher than the secondary turns or windings, we have what we call, when the primary is higher than the secondary, we have what we call step down. This is higher than this, than the secondary. We have step down. In step down, that's why from the high tension down to the distribution line, we have step down. So all the one that we use even in our electronics, we have 220 volts to 12 volts, 24 volts, 36 volts, 5 volts. Sometimes we have multiple voltage outputs of less than 220. They are all step down because of what? The primary windings are higher than the secondary windings. However, when we have the opposite, when the primary windings lesser than the secondary. In other words, when the secondary windings are higher than the primary winding, we have step up. This time less, this is higher, so we have step up. That is why from the generation to transmission line, we have step up transformer. So step up transformer, basically they are used in transmission lines. These are the uses. And what do we have that we must know? There are some things when we are talking about construction of transformer. You may ask me, before I move to the construction, by what principle does it work? It also works with mutual inductance. This is the principle behind transformer. Mutual inductance. Unlike electronics motor, it moves with electromagnetic induction, but here is mutual. They are sharing the frequency together. So the voltage in is either step up or step down. Mutual inductance. That is the principle behind it. Then the construction. We have the iron ore. We have the laminated coil. Then special arrangement is made on it. Its number of turns. This primary, this secondary, this one, this iron ore. Then the purpose is to reduce its loss. Sometimes we call it its loss, we call it loss due to what? Induction of current flow. Now, from here, the maintenance. When we are talking about high voltage transformer, I'm not talking about electronics transformer, I'm talking about distribution transformer. Maintenance is required. So, maintenance is required. We have cooling oil, and sometimes we have some transformers that are using cooling fans, and we also have some transformers that are what? Air cooled. So in all this, dusting, inspection, and then the oil is what is so important. The oil must not be dry in the cylinder. I mean the housing of the transformer. So that is transformer. Basically, we have some formulas that we need to know. And then we move to formulas. Let me quickly give us some formulas that are so important in transformer. And this is mechanical expression is this. So V, that is voltage output of secondary all over the primary voltage, equals number of turn of the secondary all over number of turn of the primary, equals to current amount of current the secondary all over amount of, or you can also do it this way. You can change it, it's still the same thing. V all over V else is equals to NP all over NS equals to IP all over IS. You can make any of this the subject of the formula. It will give you the same. So with this is what we need. And we want to determine the voltage inputs, voltage outputs, number of turns in the primary, number of turns in the secondary, amount of current flowing in the primary, and amount of current flowing in the secondary. This is the formula. So we started with a transformer. What is a transformer? Types of transformer, and then you have current, you have voltage transformer, type of voltage transformer, which is step up or step down. Mostly, what do we use current transformer for? They are mostly used for what we call current reading. So mostly clamp meter is designed using current transformer as to measure the amperage of current that is being consumed by a particular load. So this is the formula and this is what we have. In practical class, we are going to see demonstration. You are welcome.